Hi, my name is Olivia, and welcome to my maker portfolio.
My first major introduction into engineering was the summer after freshman year when I built a remote-controlled shopping cart. I started by harvesting two motors off of a hoverboard, which I wired to an O-drive motor controller. I modified the firmware through the command line interface to accept PWM inputs from an RC controller and position information from Hall effect sensors. One main error that I kept on encountering was illegal Hall state, but after a few weeks of research, I found it was due to PWM noise, so I soldered a set of capacitors to act as low-pass filters. My next project was a 3D printed mechanical clock. After teaching myself rudimentary CAD for a Science Olympiad event, I pushed my CAD skills to the limit, utilizing assemblies and joints to simulate gear movements. After learning how to 3D print, I realized the frame I initially designed was too weak to support the torque required to turn the gears, so I taught myself physics mechanics to calculate more efficient gear ratios, torque, and pendulum periods. Then, for a Tic Tac Toe design competition, I nested two retracting pen mechanisms within each other to create 9 dots and rings to play Tic Tac Toe. To create the outer ring, I removed the pen mechanism's reliance on a center axis spring by replacing it with a sliding ring with 3 springs. I also learned CAM to use a CNC mill for the aluminum casing. In the end, the project won the People's Choice Award out of 50 competitors. My most recent project was a 10-foot playable piano. After brainstorming through multiple different designs and considering time and cost limitations, I decided to use mechanical switches wired to a computer keyboard PCB to play an online piano. To reduce waste, I collected used cardboard packaging from local stores to create 28 piano keys. For the actual structure, I wanted to preserve the hinging movement of a traditional piano, so I linked each key to a PVC pipe and designed a makeshift button using surgical tubing to support the front and house the mechanical switch. Each year, these projects were brought to Open Sauce, an engineering convention with 20,000 attendees, where I was one of the youngest exhibitors. I can't wait to continue making and creating in college.